All right, well, on the topic of farms, we're now going to speak a little bit to how we go from the farm to the table. Thank you all for joining us this afternoon and sticking around for the final presentation. We're going to talk a little bit about spatial analytics at Instacart. Specifically, we're going to be walking through the journey of an Instacart order and all the geospatial capabilities that we've developed as a company to create a seamless grocery delivery experience. So today we have a couple of members of our logistics team. Brian's a data scientist. Brian is a software engineer. Conrad's a data scientist. And Dmitry is a manager on our data science logistics team, and I'm a program manager on our expansions team. And we want to share a variety of perspectives on how we use geospatial across different orgs at Instacart. So first, by a quick show of hands, who's ever used Instacart before here in the audience? Okay. That's a solid number of people. We love to see it. Lots of customers in the building. We appreciate your business. For those that don't know, the minority in here, unfortunately, Instacart is the leading grocery technology company in North America. We have a four-sided marketplace where we connect over 1,500 retailers, over 600,000 shoppers, millions of customers, and food companies that are looking to advertise on our platform. And with that massive scale that we have, we also deliver to more than 95% of households across the US and Canada. But with that scale, it's been essential for us to develop and invest in geospatial tools and capabilities so that we've been able to scale and operate efficiently. And Konrad will talk a little bit more about that.
So the core part of our business model is grocery delivery, which by itself is a deeply inherently geospatial problem. Starting from which retailers that we show to you when you open the app or go to the website, to the ETAs that we show when you've added your items to the cart and you're interested in checking out, to once you've placed the order, a lot of magic that happens behind the scenes in terms of taking the orders that have been placed, trying to batch them together so that we can fulfill more orders together more efficiently, matching those to the pool of available shoppers that we have who are available to take orders, then finally routing in-store and then to your delivery address and hopefully delivering that in a seamless experience. We won't be covering that full depth or breadth today, but we'll be highlighting a couple of those specific use cases. Throughout this, there's a lot of spatial algorithms, a lot of prediction models that we're using to try to determine how long it'll take to fulfill your order, how far we'll have to drive, either a shopper driving to the store or delivering to you, and then even optimizing the route that shoppers take in store. That said, just because the delivery business itself is geospatial doesn't mean that we're always thinking spatial first or that we're always the most sophisticated in terms of the techniques and algorithms that we use. In this talk, we'll be providing a few different perspectives across a few different orgs and functions on how we use geospatial data and how we're trying to unlock the next set of capabilities. Part of the reason that there's actually four of us here is that we've formed an informal working group to try to share learnings, best practices, and methods across the different orgs. And so that's some of what we'll be covering. With that, I'll pass it back to Andrew to talk about the operations use case.
So first, we'll look at this from an operations standpoint. On my team, geospatial analysis is critical for generating insights about retailer coverage and the customer demographics of customers within that retailer coverage. We use time-based isochrones and geospatial functions to actually do the estimation of household coverage for potential new retailer partners. We also build maps out in Cardo to visually showcase that opportunity. And then we'll also enrich these analyses with census data so that we can surface some of the demographic insights. So to look at an example here, we might look at something like a retailer's coverage of food deserts, which are low income and low access areas throughout the United States. So on the slide here, you can see a town, Willisburg, Kentucky. It doesn't have access to fresh grocery for local residents. It just has a Dollar General and a Quarter Mart. And this, a retailer that could cover this kind of area may be a good candidate for enabling EBT payment on our platform. And EBT stands for Electronic Benefits Transfer, and it's what allows users to pay for food using their SNAP benefits. So by demonstrating, the populations and their demographics, we're able to communicate the value of certain capabilities of Instacart. And by developing these new partnerships, we're also able to improve our selection on the marketplace and increase access to fresh food for our customers. So when someone opens up the Instacart app, they'll actually see all the retailers that are within a 60-minute drive time. And in order to do this, we actually generate those 60-minute service areas. And then when you open the app, your address coordinates will be intersected with those service areas, determine which retailers actually surface you in the app, as you can see here on the right. So for someone living in Willisburg, Kentucky, a town without any local grocers, this means access to several retailer options, as you can see, and they all have the EBT payment type enabled, which is really a huge value for those customers. Now Konrad's going to walk through more of a data science perspective.
So from the data science or ML side, we operate in over 14,000 different cities, which introduces a ton of spatial heterogeneity, differences in city structures and layouts, how easy it is to park in a particular area, customer preferences on the retailers they order from, the types of items that they order, when they want their groceries delivered, all of that. Because of that, a lot of our models are at least implicitly spatial, if not explicitly. We try to model some of the variability in customer preferences, shopper preferences, and various other components to try to predict accurate ETAs, for example, within our fulfillment model. A lot of the time, this heterogeneity actually shows up as residuals in our performance. So we might see hotspots or cold spots of where we're frequently or infrequently delivering orders on time versus not. We also use offline analysis to identify potential new features to add into our models or identify areas where it's not working particularly effectively. For example, looking at different spatial autocorrelations or discontinuities across our internal boundaries of how we define where a particular system is active or trained on. Together, these online and offline insights help us understand our customer and shopper preferences, and that then drives product strategy in what types of new features that we offer or what types of new systems that we build to be able to optimize our performance. Talking some more about the real time and some of the challenges of compute at scale, I'll hand it over to Brian.
So on the engineering side, one of the challenges that we face is trying to identify candidates to fulfill a particular set of deliveries. Given that we have over 600,000 potential shoppers and 85,000 store locations, there are quite a few possibilities. So it's important that we find ways to reduce the problem space in order to find the ideal candidates. We use a lot of geospatial techniques in order to do this reduction of the problem space, including spatial indexes and nearest neighbor searches, geometry simplifications, and even things like geohashes. So in this example, you can see some of the subtleties that are involved when you use things like geohashes to reduce your problem space. As we all know, right now we're in the geohash DR72H. You can see us up here on the right-hand side. The circle is Learner Hall. And let's imagine for a second that we're trying to find some candidates to arrive here within a certain amount of time, to do a delivery. The candidates may be traveling by bicycle, they may be walking, they may be driving. These are all different modalities that we use for deliveries. And you can see right away when you look at this geohash that there are a couple of obvious issues with it. The first is that we're right on the eastern border, so that means we're not getting any candidates to the east of us. And the second problem is that, of course, the Hudson River goes right through it, which, it's probably, if you're like me, you get sort of annoyed at the fact that Manhattan doesn't go from north to south because the geohashes don't line up properly. So as a result, the half that's sort of the northwest quadrant, the folks in that half are going to have a much higher travel time to arrive here. Geohashes are useful sometimes. As we know, they're very fast to compute. You just interleave the binary representations of latitude and longitude, so they're super useful, super fast, but they ignore features like rivers and road networks. So we actually use a lot of shapes in order to solve some of our problems, and sort of every shape has a different purpose. So for instance, we use administrative boundaries such as zip code tabulation areas for postal codes, county borders, state borders, country borders. Sometimes we intersect shapes with each other in order to get the ideal shape. So like in the last example, if we had taken the intersection of the geohash and either the postal code or the state boundary, then we would have only had to consider the folks on this side of the river. We also use time-based boundaries. As my colleagues mentioned, we use isochrones. So here on the bottom, you can see all the places that you could reach from a certain point in Manhattan if there were no traffic in either 10 minutes, 30 minutes, or 60 minutes. And even considering the scenario where there's no traffic on the road can be useful because this sort of provides like an upper bound in terms of a search space when you're looking for folks who can reach a destination in a certain amount of time. So another shape besides geohashes, we also use hexes. They can be helpful. They're nice because they're a little bit rounder than the rectangles, and we can use those for spatial binning, even if the data itself is not uniformly distributed spatially. Yep.
Is it? We're good.
Yes.
Let's go. Thanks all for presenting. 4 presenters. Can you believe it? We're actually really excited to be here, and I think the examples that we shared are a reflection of the diversity of the geospatial challenges that we face every day at Instacart. And I think we're getting better at addressing these. I don't think we're anywhere near where we'd like to be. I'm sure we'd like to exchange some ideas with some of the folks in the audience here today. But we are getting better, and the reason that we're getting better is a result of deliberate efforts to grow and evolve our internal geospatial culture. And it hasn't always been easy. And I think that for some of you in the audience, especially those of you maybe in industry, in government, those of you in large, complex organizations, I suspect you'll empathize a bit. In fact, I think some of you might be facing some of the same challenges that we faced and will continue to face. So what we want to conclude with today was some takeaways from our own geospatial journey at Instacart, some lessons to end the day with. So let's start with this, and I think this is going to be obvious to this crowd here. Everyone loves a map. Maps are powerful tools for visualization and engagement. We know that, you know that. Unlike other visualizations, however, maps are really distinct in their ability to cross-reference spatial context into data. And what does that mean? Well, I think many people here are from New York. I'm not. I live in San Francisco. But when you look at a map of New York and you see a heat map of some pattern, some activity, well, like your brain is instantly triggered to build an intuition as to why you're seeing that. And that's because you have that familiarity, you have that domain knowledge about New York. And it's the same thing with your stakeholders. If you're working with different groups inside your own company who may not be geo-first or even geo-interested, take their data, put it on a map, you will get interest. So let's move on. For large organizations, building top-down alignment towards and adopting wholesale geospatial decisions, especially ones that span across orgs and teams, this can be difficult. I think you saw just in Brian's last example, we're using geohashes, we're using hexes, we're using isochrones, we're using zones. It's a reflection of the actual challenges of it being a coordination problem. But what we found was sometimes it's better to be able to have geospatial capabilities than to have nothing at all and to focus first on alignment. And in practice, we found that we've had better luck with bottoms-up approaches, grassroots initiatives, using off-the-shelf, out-of-the-box capabilities where it makes sense to do so, using open-source tools. This allows us to minimize risk and allows independent teams to develop locally and independently. Put another way, these types of MVPs and POCs, they might have a funny tendency of defining our standards, for better or for worse. But what we found is sometimes it's better to have a lack of disagreement than to prioritize universal agreement. And that ties into my third point, right? Like when we're designing these geospatial tools and solutions for our internal stakeholders, one thing that we try to prioritize is usability. Ask yourself, who are you building these capabilities, these solutions for? If the goal is to make your organization think more geospatially, you're going to have more success through easy to use but widely adopted tools. We've seen a lot of really cool cutting edge stuff today. I was glad to be able to catch most of the presentations. It's really fascinating. And I think we're going to get there, but we're going to get there at different paces, and it's probably better for us to have something that's widely usable, widely adopted, and then allows us to build on top of it. Cool. Thinking about time, let's try and wrap it up here, and I'll wrap it up with this fourth point. It's a point that I think has particularly resonated with me recently, is this notion that geospatial adoption tends to be nonlinear. There's going to be parts of your organization for whom it's going to click instantly. But that aha moment of the utility, the value that geospatial capabilities add, that's not uniformly distributed. Some teams, some stakeholders, they're going to pick it up right away. Others, you're going to have to be patient. You're going to have to hold their hand. But it's truly the folks who are geo-agnostic, if you can convert them, they become the strongest geo-advocates in your organization. And that's how we have had a lot of success internally, building that momentum, building more of that alignment and consensus to both develop and invest in geospatial capabilities. And truth be told, they've unlocked a lot of wins for us. I'd love to share a little bit more about that, but I think our comms team might get quite mad at me if I do that. So let's leave it with that. I also want to say thank you to my colleagues for presenting. Thank you to Ricardo for having us here. And thanks for the audience for sticking with us to the end of the day. Hope to catch some of you later today.